Okay folks, this is going to be a quick video on the solutions for the homework task number 2, simple machines. Question 1 was a question that was based on the example that we covered in class. So the first thing you need to work out here is you start with the velocity ratio. So we know that if this was an ideal machine with 100% efficiency, that our velocity ratio, I'll just try and get our pen working here, our velocity ratio would be equal to our mechanical advantage. But we know that that is not the case, okay, because we already know that in this question we have an efficiency of 54%. So for this type of question you need to start with the idea of the velocity ratio. Okay, so velocity ratio is going to be worked out by looking at the number of ropes that are appearing in this pulley system, or the number of pulleys most often. So of course that's dependent on the configuration of the pulleys, but for this instance it's a normal pulley system. So we've got either 1, 2, 3, 4 ropes. You can see the ropes there, 4 across, or you can count the pulleys, 1, 2, 3, 4. So we know we're going to start this question off with the idea that velocity ratio is equal to 4. So that's the first step in this type of question. We also know from our work that we did on efficiency, that efficiency, which is given by the Greek eta, is equal to mechanical advantage over the top of velocity ratio. Okay, now this eta figure here is 54%. It's expressed as a percentage here, but for this particular equation you would need to express it as a decimal, 54 over 100. So we move our decimal point 2 places. This way we get 0.54. So we can rewrite this equation as 0.54 is equal to our mechanical advantage, which we're trying to work out, we don't know yet, over the top of our velocity ratio, which we do know is 4. And then we multiply both sides of this equation by 4 because we want to get rid of that 4 that's on the bottom here. So we're going to get rid of that 4 by multiplying both sides by 4, and we end up with 4 times 0.54 equals the mechanical advantage. So we end up with the mechanical advantage is equal to 2.16. So that's how we get to our mechanical advantage. Now we need to say to ourselves, what is the weight force acting on this pulley system? And we have 450 kilos, and we know that we multiply that weight, which is a force, is going to be equal to 450 kg times 10 meters per second squared. So we end up with weight equals 4,500 newtons. Remember how we talked about weight being a force. Mass is in kilograms and weight is in newtons. So we've got 4,500, and we also know that our mechanical advantage, I'll just go over the right hand side of this page, mechanical advantage is equal to our load force, I'm going to call that FL, over our effort force, FE. And the question is asking us calculate the effort force. So we know our mechanical advantage, we've worked that out, is 2.16. And we know that's going to be equal to our load force, and our load force we worked out already. It's our weight force, so that's equal to 4,500 newtons over the top of our effort force, FE. So we need to now make effort force, I'll rewrite that because it looks like an FE, it's going to be F force and a little small e, subscript e, so for effort force. So now we're going to get our effort force to the top, so we multiply both sides by FE to get the FE away from here, and we end up with when we change the subject of this formula, we end up with the force of effort, which is what we want to work out, is equal to 4,500 newtons over our mechanical advantage, which is 2.16. And we are going to end up, when we do the maths for that, it's going to be equal to Fe is equal to 2083.3 repeater newtons. So these questions aren't that hard, but just remember, always start with VR, okay, as being the velocity ratio, because we know it's not a perfect machine because we haven't got 100% here. So start with VR, use your efficiency calculation, MA over VR, which will get you to a mechanical advantage, which is going to be less than VR because it's not a perfect machine. Okay, that's the thing you need to remember. I had a few people multiplying 54 by a force, etc., etc. You can't do that. You need to follow the steps that were in this equation. But that is your answer there. Okay, that's the effort force required. We've got 4,500 acting downwards, but we only need to apply 2,000 newtons of force, or 2,083 newtons of force, to actually move that load. Okay, let's do one more, exactly the same process, the only difference of course being not quite as much advantage in this system because it's a system that only has 2 pulleys. So we start with a velocity ratio, we count the ropes or we count the pulleys. So we either count the 2 ropes or we go 1, 2 pulleys. So what did we start with last time? We said velocity ratio is equal to 2. We also then said to ourselves, okay, so what are we going to calculate? We're trying to calculate the effort force, and we know that the efficiency is 70%. So that tells you we've got efficiency. We need to come up with a formula for efficiency that's going to get us to a solution. So we say eta is equal to, and we said last time efficiency is equal to MA over VR. You might remember MAVR, MA, mechanical advantage over velocity ratio. We know the mechanical advantage is not equal to VR in this case because it's not 100% effective. So we end up with expressing the efficiency as a decimal. 0.7 is equal to MA over VR, and we know the VR in this case is 2, and then we get rid of the 2 by multiplying by 2 on both sides, and we end up with 2 times 0.7 equals MA. So our MA is going to be 1.4. So 1.4 equals MA. So that's our mechanical advantage. So now we know our mechanical advantage. We then say to ourselves that mechanical advantage is going to be, we're going to use the formula for mechanical advantage to work out what our effort force is. And we know from other work that mechanical advantage is equal to load force, FL, over effort force. Okay, so we know that MA value is 1.4. We don't know the load force yet. We need to calculate that. We know that this weight here is 400 kilos, and we say weight equals mass times acceleration. Okay, because that's force equals mass times acceleration. And we know that what our mass is, it's 400 kilos, and we know that acceleration is due to gravity. So weight is equal to 400 times 10 meters per second squared, and that gives us a value of 4,000 newtons. And then all we need to do is say to ourselves, okay, so now we know our weight force is 4,000. We put 4,000 over the top, over FE, effort force. So all we have to do now is say our effort force, changing the subject of this equation, is equal to 4,000 over 1.4. So FE, effort force, is equal to 2857.1 newtons. And that's our answer. So that's how you do that type of question. So please make sure that you follow those steps. Start with the velocity ratio first. on the understanding that if it's not a perfect machine, you can't assume that the velocity ratio is equal to mechanical advantage. Okay, mechanical advantage is going to go down if the efficiency is less than 100%. You've got to remember that. Okay, so that's the first two questions out of the way. If you have any questions, please, by all means, email me. I'm going to have to now try and get to the rest of this page, which is going to be interesting. Okay, so let's see if we can do that. And we'll close that. And we'll say, yes, we'll save our changes. Okay. And then we'll move our page, we'll get out of here and we'll move our page up. And we'll get ourselves on the next bit of the question. Okay. The